Hello everyone, my name is Julia Woodward. I'm a PhD student from the University of Florida, and today I will be presenting our work on examining the presentation of information in augmented reality headsets for situational awareness. Augmented reality headsets allow a user to see and interact with virtual objects projected onto a view of the real world. AR headsets are being used in industrial settings such as the oil industry and healthcare industry. However, there's been little prior work on how visual information should be presented in these headsets, especially in the context of situational awareness. Situational awareness is the perception and understanding of the surrounding environment, and it's crucial in safety-critical domains such as the military and healthcare. For example, surgeons must monitor a patient's heart rate during surgery and act quickly if there is a problem. Poor situational awareness has caused industrial accidents such as airplane crashes and oil spills. Augmented reality has been shown to increase situational awareness using computer screens, tablets, and other display screens. For example, Park et al. Created an AR system for increasing situational awareness while driving. Uh, on the car windshield, it had overlay of colors to show the distance of other vehicles. Also, Ruano et al. Created an AR system to improve the situational awareness of unmanned aerial vehicles. The flight data was overlaid onto a live video on computer screens. In this image, it is from Ruano et al., showing the markers over the live video. Prior work has also started looking at the potential of using AR headsets for situational awareness. Liu et al. Looked at using AR headsets for aiding anesthesiologists and monitoring patient information. In a simulated training environment, they saw that using the AR headsets increased efficiency. However, they didn't examine how visual information should be presented in these headsets. Since AR headsets are being used in industry and have the potential to improve situational awareness, it is important to study how information should be presented in these headsets to maximize situational awareness while minimizing distractions. Visual information in the context of awareness can be split into two categories. The first being central or critical information such as hazard warnings that are very time sensitive. The second being peripheral or secondary information that might not be as essential. While critical information should always be visually salient, secondary information does not have this constraint, which allows for larger amounts of detailed information, such as item descriptions. And there is also increased opportunities with how it can be integrated with the environment. Therefore, for our study, we examined 3 different presentation styles in AR headsets for textual secondary information. The first being locked to the display view or display, located in the environment, and a mix of both. In our study, participants completed math problems on a tablet while monitoring the information in the different presentation styles in the AR headset. For the information that was presented in the headset, it included the average math time presented in minutes and seconds. So this is the average time it took the participant to complete the math problems, as well as the math accuracy, which was the ratio of correct answers over completed problems. And both of these updated in real time after each problem. There was also a random word that would cycle between banana, apple, orange, and lemon, and this would randomly switch after 20 to 40 seconds. The random word was used as a proxy for information that might not be directly related to the main task, but still necessary for maintaining situational awareness. And these 3 different information categories were always presented in the same order. To now go through each presentation style, the first one being display. The information was always locked to the left-hand side of the display. And now I'm going to show a video showing the functionality of the math application as well as how the presentation style looks. So in this video, you can see the participant is completing the math problems on the tablet, and the information is locked to the display in front of them. So when they move their head left to right, it always follows the movement of their head, and the problems update in real time. For the environment, the information was fixed to the left-hand side of the environment. As you can see in the video, the participant is looking down at the multiplication problems to solve it, and they can no longer see all of the information in the environment there because it is not locked to the display, but rather in the environment. For the last presentation style, this was mixed environment. It was locked to the left-hand side of the display, like the display presentation style, but it had the same distance and height as the environment style. Having the text further away made the text appear less spread out and further into the participant's central vision, as you can see in the video. For our task order, each participant completed 3 study blocks for each presentation style. They first completed a practice math block where they were not wearing the AR headset, and this was just for them to get familiar with the math application. They then completed the first study block with the presentation style, and this was 5 minutes, and each study block was 5 minutes each. After each presentation style block, they would complete a survey, as well as the NASA TLX survey, which was used to look at perceived cognitive workload. And in our study, we counterbalance between the different presentation styles. For our participants, we had 30 adults, 11 female, 18 male, and 1 identified as non-binary. We did not recruit participants who were dyslexic, and all had normal or corrected to normal vision. For our evaluation metrics, we first looked at the recall of information accuracy. So in the survey, after each presentation study block, we asked what the last presented information in the headset was. And we did not tell them beforehand that we were going to be asking for this information. We also looked at perceived cognitive workload using the NASA TLX survey, as well as the error rate and problem solve time in the math application. We looked at the math application metrics in order to see if the participants were focusing on the main task of the math instead of monitoring the information in the headset. And the last thing we looked at was subjective preference between the presentation styles. So we did not see any significant differences between the presentation styles for the math metrics. And this is good because it shows the participants were focusing on the math instead of monitoring the information more between each presentation style study block. We also did not see any significant differences for perceived cognitive workload, which shows that the main task was consistent between the blocks. As well, we did not see any significant differences for subjective preference. However, we did see a significant difference for the accuracy of information recall. As mentioned, in our study, participants were unaware for the first survey that they were going to be asked to recall the information in the headset. But after completing the first study block, they then were aware for the other 2. Therefore, we separated analysis into 2 categories. The first was unaware recall, which was when they were not aware that they were going to be asked to recall the information. And this captures more of the raw perceptibility of the information in the headset. However, we did not see any significant effect for unaware recall. The other category of analysis was aware recall, and this coincides with more real-world settings where the user would be aware of their main task and what they had to monitor. And we did see a significant effect of presentation style for aware recall. And looking at aware recall, so when the participant was aware that they were going to be asked to recall the information, we saw significantly higher recall accuracy for the environment presentation style when compared to the mixed environment presentation style. We then examined each secondary information separately, which was the math time, math accuracy, and random word, and we only saw a significant effect on random word accuracy. We then tried to further examine the results to see why the environment style had a higher accuracy recall. When comparing environment to mixed environment, only the random word was significant. Participants frequently remarked that they were more interested in information that pertained to the main task, which in our study was the math time and math accuracy. So the participants focused on that information throughout each presentation style study block. By random word being significant, It shows that the environment style was highly perceptible since the participants had a higher recall even though they weren't mainly focusing on it, like the math time and accuracy. And looking at the mixed environment, participants said that the mixed environment was more distracting and that they found it always in their field of vision and their main field of vision. For example, participant 13 said the mixed environment was too distracting and put too much pressure on me to get more problems right. When looking at the environment and display, both environment and display improve perception and comprehension for secondary information. Participants remarked that the display was easier to tune out the mixed environment since it was more in the periphery. As well as for the environment style, participant 8 said the environment style didn't get in my way, so I didn't have to block it out of my vision while completing the math problems. It was nice to look up at it when I felt the need to. So for both the environment and the display presentation style, participants preferred it in the periphery so they can tune it out when focusing mainly on the main math task. In comparing environment to the display presentation style, prior work has shown that text notifications locked to the display result in higher sense of urgency. And since secondary information should not require a sense of urgency, we recommend to utilize the environment presentation style for non-essential secondary information and the display for more important information. In conclusion, we conducted a study on how to present secondary information in an AR headset for situational awareness. We recommend to use the environment style for more secondary non-essential information and the display style for more pertinent information. For our study, we only examined secondary information. For future work, we are looking to combining both critical and secondary information in a real-world task to see if design recommendations for the information style differ when cognitive workload increases. Thank you very much, and that is my talk.